Step 1. Identifying the IP address of the server Linux machine. Click or double-click the terminal app icon, or press Ctrl+Alt+T to bring up the terminal window. Type ifconfig into the terminal window. Press Enter. Doing so runs your command and displays the IP address information of any network items, including your computer. Step 2. Modify the hosts file on the client Linux machine. Modifying the hosts file enables us to override the domain name system for a domain on a specific machine. To do this, open up a terminal window on the client Linux machine. Click or double-click the terminal app icon, or press Ctrl+Alt+T to bring up the terminal window. Enter the following command to open the hosts file in a text editor. Enter your domain user or super user password when prompted. Enter the relevant details of the server Linux machine into this file. The first field is the numeric IP address of the server, and the second field is the canonical or fully qualified domain name that can be used to easily associate with the server later on. We will be referring to our server as EE542 Lab1 server. Confirm the details entered, save the file and close the editor. Step 3. Verifying the client-server model operation. First, let's start with the simple model. Navigate through the codebase folder structure on both the server and client machines, and identify the folder named nonconcurrent, single, server. Navigate into the folder, and run the make command, in order to compile the source code files. Now, let's begin by launching the server application first. To do so, execute the server application, with the port number as an input argument. This is the port on which the server application would listen on and accept incoming requests from clients. Be sure to select a port number higher than 1023, such as 2500 in our case here. Next, let's execute our client by specifying the domain name of the server, as configured during Step 2, that being EE542 Lab1 server in our case here, followed by the port number, 2500 in this case, as input arguments. Enter a message of your choice, when prompted for, on the client side. If all works out well, the same message should show up on the server terminal, and the client terminal should display a new message acknowledging reception by the server. Next, let's observe the same model, but with a concurrent server in place. A concurrent server is one that can handle multiple clients, in parallel, at the same time. As before, let us begin by navigating into the respective folder, on both the client and server Linux machines. Execute the make command, in order to compile the files. As before, let's begin by executing the server application, on a port of your choice, that being 2600 in our case here. Next, launch the client application with the necessary set of input arguments as done earlier, with the port being 2600 this time around in our case here. Enter an appropriate message to be transmitted, and verify operation by confirming reception of the message, on the server terminal, and a subsequent acknowledgement message on the client terminal. The current implementation of the concurrent server, however, fails to handle the scenario, where the child process created in the server, becomes a zombie process. This can be verified by opening up a separate terminal on the server machine, and entering the top command. Look for the zombie field at the top right corner of the terminal window. The count keeps increasing, as we initiate more and more client requests. Now, let's take a look at enhancing the concurrent server, so as to handle zombie processes. Executing the improved concurrent server application, following the same set of steps mentioned earlier, we can see that zombie processes are no longer being created here. Next, let's take a look at datagram sockets. Once again, compile the files in the respective folders on both the server and client machines. Launch the server application first, followed by the client application, send a suitable message from the client over to the server, and confirm the transaction across datagram sockets. Next, let's take a look at Unix sockets. A Unix domain socket is a data communications endpoint for exchanging data between processes executing on the same host operating system. Unix domain sockets use the file system as their address namespace. To verify this, compile the files as done earlier, and execute them to confirm proper operation. Finally, let's take a look at the single-process concurrent servers, in which case the arrival of data is used to trigger processing. Steps to be followed here is similar to that covered earlier in this video. Thank you.